What's up everyone, this is Carlos and today we are solving the problem called showering and it's from Codeforces. Here's what it says. As a computer science student, Alex faces a hard challenge, showering. He tries to shower daily, but despite his best efforts, there are always challenges. He takes S minutes to shower and a day only has M minutes. He already has N tasks planned for the day. Task I is represented as an interval LIRI, which means that Alex is busy and cannot take a shower in that time interval. At any point in time, strictly between L and R, LI and RI, no two tasks overlap. Given all n time intervals, will Alex be able to shower that day? In other words, will Alex have a free time interval of length at least s? Okay, so let's see the input. But actually, before going into the input, um, I like this problem, and it's simpler than I initially thought. And here they gave us an image. So, for example, in the first test case, well, actually, let's go through the input real quick. I mean, as always, the first line contains a single integer t, the number of test cases. Then, the first line of each test case contains three integers n, s, and m. And here we have the constraints for each of these values. And it says the number of time intervals Alex has already planned, that will be n. Then, the amount of time Alex takes, the amount of time Alex takes to take a shower, that would be s. And third, the amount of minutes a day has, that would be m. And then following it says then n lines follow, the ith of which contains two integers, li and ri. Okay, and it says the time interval of the ith task. No two tasks overlap. Great. And then additional constraint on the input, li is greater than ri minus 1 for every I larger than 1. The sum of n over all test cases does not exceed 2 times 10 elevated to the fifth. Uh, I forgot the word in English for this, but you get the idea. Output. For each test case, output yes without quotes if Alex can take a shower for that given test case, and no also without quotes otherwise. You can output yes and no in any case. Okay, and you get the idea for this. Great. So, this is a good problem, and I personally like it. So, we can see the first input. Let's say we have, or sorry, the sample input, and it says we receive four test cases. So for each test case, we receive the appropriate n, s, and m values. In this case, uh, Al Alex had, for this test case, had three tasks planned for that day, and it would take him three, let's say, minutes to take a shower, and the day will have 10 minutes. I mean, yeah, I mean, let's think about those like minutes, for example. So yeah, um, the thing about this is, um, all we have to do really is think of the day or the minutes in the day as a line. For example, like literally in this image. It, here you can see that if we take the 10 minutes on this day, we can visualize this in a line. So, for example, the day would start at minute 0 and 1, 2, so on and so forth. So here we say we see that Alex has three tasks planned for that day, and the first task will start at minute 3 and will end at minute 5. So on this image, we can see it. The task is starting at 3 and ending at minute 5. So between in that time interval, he cannot take a shower. And then he has some free time because his second task will begin at 6, but it will last up until 8. So he has free time here, but that's not enough free time for him to take a shower. Because remember, in this test case, for example, it would take him about 3 minutes, not about, but exactly 3 minutes to take a shower. So here he would only have 1 minute, and that's not enough. And the same idea applies at the end, uh, because his third task starts at 9 and ends at 10. And here he again has only 1 minute, so that's not enough. But as you can see on the image, since his first task will start at 3, he has exactly 3 free minutes at the beginning of the day so that he can take a shower. So that's why for the first input we all put yes. Okay, so hope that makes sense. Now I also want to go over this other input real quick because it exposes uh, not and I won't say edge case, but a different angle of this problem, and that is what happens is, for example, and you can see here the time intervals. We have a 1, 2, 3, 5, 6, 7. Okay, so we have three tasks for that day. It would take him 3 minutes to take a shower, and we have 10 minutes total in the day. So for this one, I generated this image with the help of ChatGPT in order to have a visual cue of what's happening here. So as you can see, we have the task here defined from 1 to 2, from 3 to 5, and from 6 to 7. So those time slots are taken. So since we need again 3 minutes at least of free time, we cannot take the shower between 0 and 1 because that would be only 1 minute. Likewise here, from 2 to 3, that's not enough time. 6 to 5, that's not enough time. But at the end of the day, we have plenty of time. And the main idea of this problem really is we have to go through each of the time slots and we have to compare, um, let's say, um, how at which time the previous time slot that was taken ended. So, for example, let's say on the beginning of the day, because it's the day has just started, there are no previous tasks. So the previous task literally does not exist, but we can take 0 as the reference as the beginning of the day. So we can say, uh, since our first task starts at 1, we can compare 1 to 0, and from there we can take how many free time or how many minutes of free time we have. So for example here, if we do 1 minus 0, we have 1 minute of free time. And then we can declare that that's not enough time because we need 3 for this test, at least 3 minutes for this test case. Then we can move on to the next task, which would be from 3 to 5. But in order to determine what we care about, we can compare 3, the time at which this task begins, and 2, the time at which the last task, because now there is a previous task, unlike the first test case or the first case. And because we now have a previous task, we can say 3, the time this task begins, minus 2, the time the previous task ends, and we can see again that 3 minus 2 is 1, so 1 is not enough time, and so on and so forth. You hope you get the idea. But what happens, like here, when we get to the final task of the day and we still haven't had enough time to take a shower? Well, instead of comparing this, or rather, think about it, what would you compare this to? Since this is the final task of the day, like there's literally no next task, at least not for today. But we can compare it to the time the day ends, so to speak. In this case, the day ends at minute 10, and we can say 10 minus 7, and that would give us 3, which is exactly the amount of time it would take for it would take Alex to take a shower. So that was hopefully somewhat useful explanation conceptually of what we're going to do. And here you can see that this second test case or sample input would output yes, because uh, at the last hours or last minutes in this case of the day, we would be able to find the time to take a shower. Hope that makes sense. I'm going to go ahead and do the coding part. As you can see, I already did the basic boilerplate for the t-test cases, and now we can begin by taking n, s, and m. N, s, and m. You've seen this before, n, s, and m, like that. And then um, we have to we're going to have to loop, to iterate for each test case n times in order to take the n pairs or the n lines, right? So we can do something like this, int I equals 0 as long as I is less than n. And I mean, there's like other ways you can go about this, but I just want to keep it like this for this problem. And here we can take, or rather than we must take L and R like this, like this. Okay, and then here inside this for loop is where we're going to do the logic that I explained in the image. So before that, right now we have like almost all the information, or at least the conceptual blocks we need to rather build, or the explanation I just give you in C++, but we are still missing a one key thing, and that is our point of reference for when the day uh, starts. And in this case, we're going to call it prev to refer to the previous value, or the time at which the previous task ended. And as I explained already, at the beginning of the day, there's no previous task, so that's why the starting state for this value is going to be 0, aka the time at which every day starts at 0. Hope that makes sense. So we have that, and then we are going to have a string a string which I will call ans for answer, short for answer, and this is going to be default no, because as you will see in a few minutes, the conditions that we will evaluate will um, will uh, will evaluate if this can be a yes. But if that's not the case, then this will just sorry, yeah, if that's not the case, this will just stay as a no. So from here, you can take the explanation I just give you and say something like, for example, um, if you take the value of yes, no, sorry, I am not making any sense. You just have to take the value of L and R and do the comparison. Let's say if L, sorry, if yeah, if L minus um previous is greater than or equals to S, then we have found our time slot for this. So we can say something like this. Yes, answer yes. So just like that. And that would be pretty much all there is uh, to it, because at the first iteration, let's say we have L is going to be just for the first input, it's going to be 1, and let's say 1 minus 0 is going to be, no, apologies, it's going to be 3. 3 minus 0 is going to be 3, which fulfills the condition, and like that we can change this answer from no to yes. Hope that makes sense. So now all that's left to do is change our point of reference. And now the new point of reference is going to be the time at which the current task ends. And we do something like this. Oops, not like that. Sorry. Pref R, just like that. And here we're pretty much done for the loop, because this would implement the logic I explained earlier, just like that. And here, all we have to do, or all that's left to do, is take into consideration that last bit in which, let's say, you reach the end of the day, but you still haven't found a time slot. So now you just have to compare the end of the day with your last point of reference, or and by that I mean the time at which your last task ended. So you can do something like m minus m, because that's how many minutes there are in the day, minus brief, which will be your last point of reference. And here you we care about the same thing, if this is larger than or equal to s, because if so, we can change the answer to yes, just like this. And let me change this just for consistency's sake. Yes. And then from here, um, all we have to do is print the answer, just like this. And this should be good. This should work, but let's give it a go with the sample test case. Yes, yes, no, yes. Yes, yes, no, yes. Seems to be good. Oops, I indented accidentally. Didn't want to do that, but let's give this a go. Showering, success. Let's submit it. Thank you. And it got accepted. So right now, for this problem, the time complexity would for each test case would be O of n, because for each test case you have to process the end lines, or meaning all the tasks for that day in order for you to determine if a time slot exists. So hope that was helpful, and that's it from me.